Hey guys, welcome to day 8 on Chain Rule Part 2. Here's where we're going to tackle some of the more um, difficult scenarios of chain rule. So last time we had that last problem where it was chain rule of chain rule, and here we might see some more complicated things we might need to do it. So let's start with the first one just as like a quick warm-up, start off nice and easy, and then work our way to the harder problems here. So recall, the strategy I use is completely up to you in terms of what you want to use or how you want to use it, excuse me. If you already have a pattern or find a way to do it mentally, skip these steps, totally fine. But I'm just doing it in case you prefer the laid out steps here. So let's take a look here. We've got sine of 4x. And so inside here, let's figure out what a, or the outside function, we call it a, and the inside function is b. If you prefer the inside function first, whatever is in parentheses or whatever is being grouped or contained by something. So it seems like the 4x is being contained by the sine, and hence why I'm going to write it like this. So we now find a prime, which is cosine of x, b prime, which is equal to 4, and now we apply chain rule. F prime of x is equal to derivative of the outside function, which is cosine x. But before I write x, instead of x, I put in the inside function, which here is 4x. And then multiply this whole thing by the derivative of the inside function, which is given to us as 4. So clean this up now. We get 4 cosine of 4x. Not too bad. All right, let's jump to one that's a bit trickier, involving trig. And what I mean is, before I get there, number 4, little hint, recall cosine squared of x is the same thing as saying cosine of x quantity squared. So hopefully you see the chain rule involved in that. What's the outside function? What's the inside function? Let's do number 5, because I'm plenty sure that some of you guys are going to have, actually all of you will probably have questions on this. And so really the first thing we should address is when you're going to take the derivative of this, you should instantly be thinking, okay, have we ever taken the derivative of tangent before? Let's just do this exercise real quick, okay? Well, what is tangent? Oh, well, tangent is simply the same thing as saying sine of x over cosine of x. And then you're like, oh, Mr. Park, but we got to do quotient rule. Do we really have to? You could if you wanted to. I'm going to change it one more time. Sine of x times cosine of x to the negative 1. Now it's a product rule problem with the chain rule attached to it, but I prefer that. I don't know about you. And so now we can do chain rule here. Watch. In this case, we're going to start with the product rule. So product rule is the first derivative of the first function times the second function plus second function, or first function times the derivative of the second function, right? So if we go about that, that's going to be f prime of x is going to be sine of x, derivative of the first. So it's going to be cosine of x times this guy. Hopefully you see what happens here nicely. Then you add the first function times the derivative of the second function. Okay, so what is the derivative of the second function here? And that's where chain rule is going to apply. So what we're going to do now, it's getting a little weird, but once you see the shortcut here, it becomes so much easier. What we're going to do now is we're going to do a of x, b of x. If we take a look here, cosine x seems to be inside, so we're going to call that b of x. And it seems like it's whatever raised to the negative 1 is the outside function, so we'll call that x to the negative 1. So that means a prime of x is equal to, let's see, that's going to be negative 1 over x squared. Hopefully you've gotten pretty comfortable with the power rule, so that should be pretty quick there. And then b prime of x is equal to, in this case, negative sign. Okay, so that means this term right here that we're missing from the original problem, f prime of x, is going to turn out to be, in this case, it's going to be derivative of the outside. So let me move all this because I realized I didn't do a good job of giving myself enough space here. Let's move it up a little bit. There we go. Okay. And then we'll just say this arrow is going to go a little bit higher here. Let's do that. Okay. So it's going to be a prime of x, which is negative 1 over originally x squared, but when we replace the x with b of x, the inside function, that's going to be cosine of x squared multiplied by the inverse, or not the inverse, sorry, the derivative of the inside function, which is, in this case, negative sine of x. Now all we gotta do is clean things up, and hopefully you realize this becomes very nice very quickly. So we take a look here. First term here is just gonna cancel out. Let's put that in red because cosine x over cosine x is 1. So we get 1 plus, let's now try to combine some things together. So I see a sine of x here and a negative sine of x there. I also see a negative here as well. So two negatives cancel out to a positive. Sine times sine is sine squared. So we get sine, let's do sine of x like this, squared, divided by cosine of x squared. Okay, we're getting there. So that means now, if I think about that, that is going to break down to 1 plus, if you guys get the gist here, this is tangent squared Okay, so then you might think, Mr. Park, okay, so is that our answer? The derivative of tangent is just 1 plus tan squared? Not quite. If you recall, our trig properties, or not, yeah, our trig identity, sine squared x plus cosine squared x equals 1. There is one particular ratio, which in this case, cosine, so it's going to be this one, where it's you divide everything by cosine, you get tangent squared plus 1 equals secant squared. So either we can use the one that we just found out, or my preference is to use secant squared. Because what is secant squared? Secant squared is just 1 over cosine squared. Ah, that's something that's more comfortable. So either one, so either this one or this one is the one we can use. Let's see how it works out in our problem. Okay. So this is a problem within a problem, but let's focus on what's going on here. So we've got a whole bunch of things going on. Let's rewrite this out. This is going to be quantity. Let's do square bracket. Tangent of negative x squared, and then this whole thing is being squared. Okay, so let's break this down. I might need to move the things on the right over here, and sorry if it's going to block the way. I'll just make sure on my computer screen it's not going to block it when I talk about it. So to take the derivative, we need to first figure out the outside function, a of x, b of x. Inside function is simply a tangent of negative x squared. Cool. Outside function is x squared, not too bad. So a prime of x is equal to 2x. B prime of x, and this is where we're going to have a problem because we can't take the derivative of tangent yet. We know the derivative of tangent x is whatever we just found here. In this case, though, it's tangent of something on the inside. Oh, chain rule within chain rule. Okay, so let's try this. I'm going to zoom out. Let's go ahead and move all of this over. Of course, my pen chose not to work there. Let's try that one more time. Lasso tool, please. Thank you. Okay, let's scoot you all over just a smidge. I'll bring you back in a minute and organize this better. Okay, so that means let's bring this over here now. So that means I realized I just changed all those colors there. Okay, there we go. Sorry, it's a little laggy here. So do that, erase. There we go. Okay, so to find what b prime of x is, we got to do, in this case, I'll use c and d. C is going to be the outside function of b of x. And wow, geez, goodness, c of x, goodness. And then d of x is going to be the inside function of b. Okay, so again, the reference point now is tangent of this, right? We're getting closer to something easier, but we still need to fix this out. So inside function is negative x squared. We'll call that the d of x. And the outside function is going to be tangent. Okay, notice how what we did on the right is going to be super helpful now. C prime of x is simply going to be, in this case, and I think my pen width is a little too big here. Let me just check here. Oh, never mind, just me. So tangent of x, we can either pick over here on the right side, 1 plus tan x or 1 over cosine x squared or secant squared. I'm going to probably go with secant squared, honestly. Simpler, easy to write. And in d prime of x, this becomes negative 2x. Okay, so let's go back to b prime of x over here. So what happens is then we have to do derivative c of x, but replace x with d. So that becomes secant squared of negative x squared times the derivative of d of x. So if I clean this up real quick, we're going to get negative 2x. Let's put it in front, and then we'll have the secant squared afterwards. Secant squared of negative x squared. Whew, okay, let's finally get this all together now. So finally, once we get ourselves organized here, f prime of x is going to be equal to, we now go back to a and b because those are the original outside and inside functions, respectively. We take the outside function, a prime of x, of the inside function. So replace the x with tangent of negative x squared. Whoops, a daisy. Let's try that again. Cool. Times, here we go, b prime. So b prime we figured out was negative 2x quantity secant squared of negative x squared. Negative x squared. That and that. Okay, let's clean some things out right now. So everything's going to be multiplied, so I can multiply that negative 2x out front. So we get negative 4x. And then what we're going to get now is going to get quantity tangent of negative x squared. And then this ridiculousness of secant squared of negative x squared. Okay, usually I'll tell you guys to pause when you can't go any further, but technically we could break this up. if we look at our two trig functions, tangent is just sine over cosine. So sine over the cosine. And then secant is simply going to be 1 over cosine squared, which will then lead us to this final atrocity here. So it's going to be cosine cubed. So is that a cleaner answer than what we originally had? So either you would say, hey, Mr. Bright, that might be a clean enough answer, whereas I might be like, this could technically work as well. Depends on the context of the problem if I'm asking you to do fractions or not have fractions. In this case, I would take either one. I would honestly take either one because realistically, there's nothing you can do with that ridiculousness. Yeah, we'll leave it at that. Okay, so breathe. Difficult problem simply because we haven't talked about the tangent, or maybe we did and it just completely haven't. I missed it on one of the notes and I didn't tell you guys about that. So my apologies if I completely missed that. But again, always think about how can you manipulate an expression or an equation to work in your favor. Just like we did for number 1, or actually, where is it? Just like we did with the tangent, right? Instead of it being a quotient rule, I made it a product rule with chain rule involved into it. Now again, some of you might be like, Mr. Wright, that's just too much work. Again, because you're not comfortable with chain rule. For me, chain rule has been used so often whenever I'm tutoring calculus or teaching this portion of calculus that it just becomes second nature to me. And it's easier for me to think about it as product rule because again, order doesn't matter. And secondly, chain rule is just so like second nature to me. So if you want to use quotient rule, totally fine by me. Do what works best for you. But just know I have one less rule to memorize. So there's that. Okay, let's keep going. Let's pick another one here. This one kind of looks like the one we just did, but just an easier version of it. So we're going to just bypass that. Let's try 15. Why not? Let's try 15. I'm just checking my time here. I'm already at 12 minutes. Okay. I mean, do you really want me to go further than this? Like, I feel like you guys are tired of hearing me talk like on these videos in the first place. So if you want, send me an email or remind text me like, yeah, Mr. Park, keep going. Or be like, no, stop. You talk too long and you rant too much, just like I'm doing right now. Anyways, all right, so 15, let's take a look here. So initially, your thoughts could be quotient rule. Again, I prefer not to use quotient rule, and it's ironic that I teach you quotient rule, but again, I'm just showing you here are the tools in your toolkit, and if I've been telling you this tool can be used in other ways, then why not, right? So here's what I'm going to do. I don't like the fraction. I'm going to change it. So it's going to be y is equal to x. Let's change the exponent, or the radical down there. So the radical, it's going to be, in that case, 1/2, but it's going to be negative because I'm going to bring it up top now. So that means it's going to be this. Okay. I may have shot myself in the foot there, but we're going to just roll with it because I am a man of my word. I'm going to try doing this without using quotient rule. So in this case, let's break this up in a little bit here. This is going to be product rule because we're taking the product of two things. It's going to be that times that, as disgusting of a mess that is. Okay. So let's try this. So product rule, y prime is equal to, here we go, let's see. Derivative of the first term, so it's 1, okay, easy, times the second term itself, so easy. That's just going to be x squared minus 1 to the negative 1/2. Not bad, not bad. Okay, plus, take the first term, and now is the fun part, derivative of that second term. I'm going to underline in orange. We need to find a derivative of this guy. So let's pop it on over here. Let's start with the outside function. We know it's chain rule because we have stuff parentheses on the inside and then raised to a certain power, and that's going to be the outside function. Inside function is going to be x squared minus 1, not too bad. Outside function is going to be whatever's on the inside raised to the negative 1/2. So, what on earth happened there? Okay, a prime of x is equal to, pull the negative 1/2 down, and then you're going to subtract 1, so it's negative 3/2. So that means, do some quick math here, that's going to be negative 1 over 2x to the 3/2. Do I want to write it as a rational? Let's be consistent for now. We'll deal with the rational later. Since we're putting in the into exponent at this point, might as well be consistent with that. And then b of x, we get that. Okay, so that means the derivative that we need to stick in here, again, that was the original goal. We need to stick the derivative in here. So the derivative of this is going to be a prime of x. Okay, so let's, we'll keep it in orange just to help us out here. 1 over 2x to the 3/2, but we replace the x with b of x, the inside function, which is x squared minus 1 raised to the third power, but we're taking the square root. Okay, got it. And then that means we need to finally multiply this whole shenanigans with this b prime of x function. So what I'm going to do is I'm going to cheat. I'm just going to stick it on top because I know if I multiply it, it's basically going on top. 2 of x. Okay, let's clean some things up now because we basically found y prime. We're good to go. Just need to make sure it looks nice and pretty. So what can we do here fairly quickly? We know for a fact the 2's will cancel out there. Okay, I'm just going to rewrite the second half here. I'm trying to also do the first half, but maybe taking things one step at a time is better, as I tell you guys and pick on you whenever you don't do it in the first place. Okay, so minus is going to come out, so minus, we get x squared over x minus 1 to the 3 halves. Okay, so we're thinking. Okay, so from that point, what we can do is we can convert. I'm going to convert the first one so that's a positive exponent. I prefer that right now because here's what we're going to see here. We're going to have x squared minus 1 half minus x squared and then x squared minus 1 to the 3 halves. Okay. So that means, if it helps you to see it this way, this is what I'm visualizing in my head right now. The first one, if I just worry about the denominator, technically that is going to be square root of x squared minus 1, whereas the second denominator, it's going to be square root of x squared minus 1, but the whole thing is cubed. And so what we're trying to, or what I'm trying to do right now is I'm trying to combine this so that it looks cleaner and a bit easier on the eyes. So by finding the LCD, we just need to multiply I think we got it. So all we need to do is if this is like whatever gibberish up here, it's like a fraction, right? If you're subtracting fractions together, you want to make sure that they both have the same terms at the bottom. So that means we need to multiply this by effectively x squared minus 1 squared, if you see what I'm saying there. Because this one has twice as many of the square root of x squared minus 1s. So that's really just, yeah, okay. So that means up top now we get, because that's going to be on the bottom and the top, right? Because that's how we work out with. So that top there becomes x squared minus 1. Yeah, okay, that's what we wanted. Yeah, that's what we wanted. So the bottom will effectively become square root of x squared minus 1 cubed. And then this side stays the same because it already had the LCD in the first place. And hopefully you see how some things work out now. The bottom denominators are the same. Numerators, I can cancel out the x squared, which finally leaves us with a nice-ish negative 1 over square root of x squared minus 1 quantity 3. Or, if you prefer to keep it as exponents, negative 1 over, let's see, x squared minus 1 to the 3 halves. Either answer is sufficient for you. It's ironic that I said I was going to keep everything as exponents, but oddly enough, I do like seeing radicals sometimes. Odd. It is what it is. Cool. All right, so we've done how many problems? 1, 2, load please. That one I kind of gave you a hint. That one was given. It was just a warm-up. Okay, I think I've gone through the hardest ones. I think you guys can figure out the rest of it with the essence of the hardest ones given to you. Okay, so you're welcome. I walked you through this problem especially, right? But this was a fun one too. Dealing with, radicals. Some of you guys hate radicals. I don't know why. They did nothing to you. Maybe you just didn't learn it properly in the first place, okay? All right, you got the problem set, should be, practice set, should be good to go. Let me know should you have any questions, all right?